Hello, everyone, and thank you for joining in from all around the world. Welcome to our session of the exciting webinar series, In the Known with our experts. I'm Shachar Harush, Junior Global Product Manager here at Netafim. Before we start, let me introduce today's presenter, Orit Katzir, Global Product Manager at Netafim and our sprinklers expert. Today with Orit, we will learn how to choose the correct sprinkler. We'll begin with a short history and continue with terms you need to know before choosing the right sprinkler, and many other topics which Orit will present to you in a moment. Feel free to ask questions via the Q&A tab during the talk, and we'll address them after the presentation. So, let's get started. Orit, the screen is yours.
Thank you very much, Shachar, for this introduction. I will share my screen now, and let me know that you see my screen in a presentation mode. Let me do that. Now I'm sharing.
Yeah.
I guess that you see it right now?
Yeah.
Okay. So thank you, everyone. Thank you for joining this webinar. Today in the webinar, I would like to take you to a journey in the world of sprinklers. I will start with a short introduction of the history of sprinklers, not just the Netafim history of sprinklers, but the global and then Netafim. And then I will divide this webinar to three main sections. The first section will be a short introduction about what is a sprinkler and what is a micro sprinkler and what are the differences between those two. The second section will be dealing with the factors that affect the water distribution uniformity and basic terms that you need to know when you work with sprinklers. So this part will be a little bit longer because there are a lot of things related to sprinklers that you need to know in order to have a good performance of sprinklers. And then the last and the third section, I will talk about the Netafim portfolio of sprinklers and micro sprinklers according to the main market segments that we are working with. So let's start with the history. So first, I can tell you that sprinklers have a long history. As the origin of the sprinkler irrigation can be traced back to the late 19th century when inventors like J. Lester and J.B. Porter wrote a patent on an early version of sprinkler. It was in 1871. So 1871 was the first registration of patent of a very, very old or very old sprinkler. But first, the sprinkler were used in most of the cases for irrigation of landscape. And later on, after some years, sprinklers started to be used in agriculture, in more and more in agriculture. And we all remember in the last century, in the year about 1940, the first boom and pivot centers were developed and got to the market and to the field. And in this way, people could irrigate their field in a very, very large scale with the big sprinklers. So this is a little bit about the history. And of course, that with the years, the development of this world of sprinklers brought many innovations and different sprinklers to an efficient irrigation of our fields. So this was a little bit about the history, but in general. But I want to take you to the Netafim history with the sprinklers and micro sprinklers. So as you probably know, Netafim was founded back in 1965, inventing the first dripper. But along the year, Netafim understood that they need to bring to the market also micro sprinklers and sprinklers in order to answer many different uses or field application that are needed. So in 1998, the first micro sprinkler called the SuperNet was introduced to the market. This is a pressure compensated micro sprinkler. Then later on, other micro sprinkler were introduced to the market along the years. And first we started with the orchard market segment, and then we invented and developed and produced micro sprinklers and emitter for using in greenhouses, in net houses, in tunnels, such as this Spinet for upside down irrigation, or Vibronet for upside down germination, and CoolNet Pro for humidification in greenhouses. And today, and we have also big sprinklers for open field crops to irrigate open field. And I can tell you that being a product manager in Netafim, we are always looking at the market. We are always looking for the needs of the market with the different applications that are needed, and we always bring to the market different sprinklers and micro sprinklers and systems that can answer the need of the grower and the farmer. So I can tell you that on our table there are more and more sprinklers and micro sprinklers and systems that in the development mode, and will be introduced to the market in the coming months and coming years. So after I talked about a little bit about the history, let's start with the first section, which is the difference between a sprinkler and a micro sprinkler. So first, let me tell you what a sprinkler is. A sprinkler is actually a device that distributes water in different ways. This sprinkler it has a certain volume of water that it provides to the field that it irrigates. There are different sprinkler technologies based on different rotation movement of the sprinkler itself. We can see impact sprinklers or silicone mechanism of sprinkler that rotate the sprinkler itself. But the idea is that sprinkler is a device that distributes water in a flow rate, in the volume of the water in a flow rate that is above 200 liters per hour. So, and when we talk about micro sprinkler, according to the name, you can understand that a sprinkler is a big device and a micro sprinkler is a smaller device. And a micro sprinkler, usually we use it for a different kind of application. It provides a lower amount of water per a specific time, so lower flow rate. I can tell you that the ISO standard defines the difference between sprinkler and a micro sprinkler according to the flow rate. So a sprinkler is any device that spread water above 200 liters per hour, and a micro sprinkler is a devices that distribute water in less than 200 liters per hour, or for our friends in the US, 53 gallons per hour. So each micro sprinkler has a different nozzle size and a different internal design, and each design is influencing the way that the water are spreaded out of the nozzle of the sprinkler itself. So after understanding what is a sprinkler, what is a micro sprinkler, I would like to get into the second section of this webinar, which are the basic terms that each one of you need to know in order to get the highest performance of the sprinklers that you use in your when you are irrigating your field. So I can tell you that in order to achieve a good performance or highest performance of our yield of our crop in the field, and it doesn't matter if you work in an open field or in greenhouses when you use a sprinkler for irrigation. Always you need to understand and to make sure that you select the correct sprinkler according to your field application. Always you need to make sure that you will achieve the highest water distribution uniformity in your irrigated area. It is very critical factor, and I will talk about it in details in few seconds. And always you need to consider many other factors that I will refer to when you want to design a sprinkler system that will give you the highest performance of your field. So, what are the 5 most important elements that each one of you needs to understand and to examine before choosing a sprinkler? So I can tell you there are in general there are more than 5, but I put here the top 5 that I want you to learn and to study and to remember, and let's go one by one. So first one is what we call precipitation rate and soil infiltration rate. Now, precipitation rate is actually the average amount of water that you apply to the irrigated area in a specific time or a specific period. The precipitation rate is measured by millimeter per hour. So how much water do I provide to the field or to the crop in a certain time? So before I select a sprinkler, I will ask myself, what is my crop type? What is the phenological phase of my crop? Because in different phenological phase, I need different amount of water. What is the soil type that I have? Is it a heavy soil? Is it a sandy soil? All those factors will influence the flow rate that I will, or the sprinkler and the flow rate that I will choose in order to irrigate my crop. Now, if I talk about infiltration rate, if I have a heavy soil and I provide water to this field and a high amount of water, then what will happen is that the soil will not absorb the water, and in this way we will have a runoff of water on the field, and I don't want to have that. So I need to know what is my soil type, what is my crop type, and how much water do I need to bring back to the crop. So let me give you an example of how we calculate the precipitation rate. So let's say that the precipitation rate is calculated by a very simple formula. So I'm taking the flow rate of the emitter or the sprinkler or the micro sprinkler, and I divide it by the installation pattern. So the distance between the emitter on the lateral multiplied by the distance between the lateral. Here in this example, you see two lines of sprinklers, and you see that the sprinklers, the distance between the sprinklers on the line is 1.6 meter, and the distance between the lines is 3.2 meter. And I must say that for our listeners from the US, I know that you work with the feet and inches, and in the USA imperial units, everything can be translated to imperial units. So forgive me that this presentation is in metric. But let's take this example. But it is the same. The calculation is the same. Calculation of the precipitation rate. It is the volume, or the flow rate of the emitter divided by the spacing between the sprinklers on the line and the spacing between lines. So in this case, I have our Spinet. Spinet is a micro sprinkler for upside down irrigation in greenhouses. And in this case, this Spinet in 2.3 bar is provides 70 liters per hour. And when I install it on a spacing pattern of 1.6 by 3.2, I can just calculate the precipitation rate, and by that, 70 divided by 1.6 multiplied by 3.2, and I get a precipitation rate of 13.67 millimeter per hour. Now I will ask myself, is it good? Is it bad? Is it too high? Is it too low? It depends. It depends, as I said, in the crop type. It depends on the way that we irrigate. If we irrigate in an open field or in a greenhouse, it depends on the soil type. Remember the infiltration rate of the soil. So this is one of the factors, one of the 5 factors that I'm talking about. And the second one is one of the most important thing when we talk about sprinkler irrigation. It calls the water distribution uniformity. And the water distribution uniformity is actually the way that the water are distributed in a certain area when you operate a large scale of sprinklers that you have overlapping between them. Now, what you see in the picture is an operation of sprinkler irrigation of a Meganet sprinkler. And this Meganet, here it is installed 9 by 9, 9 meters between the laterals and 9 meters between the sprinklers on the distribution pipe on the lateral. And always we will ask ourselves how uniform the way that the water is distributed in a specific operation condition. And we need to understand why is it important and how is it defined? How is it defined? How the water distribution uniformity defined? And how do we measure it? So let's go one by one. So what you see in the picture this is a picture from took from Turkey. This is a local Turkish sprinkler, and what you see in the picture is an open field with sprinklers that are overlapping between them. Now what you see here are very, very dry spots. So dry spots are not good for us because this it means that the water are not distributed in an even way on the field. This situation can lead to low yield and can lead to a damage of the plant, reduce the effectiveness of the irrigation system. So it is very important to understand that when we have uneven water distribution uniformity or uneven watering on the soil, in this way we will have trouble. Okay, in this way the performance of the yield later on the field will be very low. So it is important that we will have a very good and a very high water distribution uniformity in the field, because when we have a very good water distribution uniformity, it will influence later on the yield itself. So how is it expressed? Now I can tell you, the water distribution uniformity is indicated by three factors, three indicators. It is the CU, the DU, and the SC. The CU is a Christiansen coefficient of uniformity. It is actually comparing the average deviation of the water in each spot from the overall depth average of the irrigated area. Now, the CU can be between 0 to 100%. The highest the CU, the highest the water distribution uniformity. It means that the water is distributed in an even way on the irrigated area. The DU is also a statistical calculation. It is the distribution uniformity, and the DU express better the 25% driest area. Now remember always that in the same field, when you calculate the CU and when you calculate the DU will always be a little bit lower than the CU. Why? Because it expresses better the 25% driest area in the field that we are testing the water distribution uniformity. The SC is a different indicator. It's called a schedule coefficient. It's called a runtime multiplier. It means how much do I need to over irrigate in time in order to get all the 5% driest area in the field to be like the overall average. This coefficient, it comes from the golf court in the US. I can tell you that because if you over irrigate, then you have a wet field, and in a golf court you don't want to have a wet field. So the lowest, the SC, it means the lowest that I need to irrigate more in order to get the 5% driest area like the average. The lowest, the SC, the highest, the water distribution uniformity. So what is our goal? When we test our sprinklers and we test our water distribution uniformity, our goal is to achieve the highest CU and DU and the lowest SC. The lowest SC will be 1. This is a perfect water distribution uniformity. And 100% CU and DU, I can tell you that if we will be like God that bring the gentle rain. A gentle rain can be water distribution uniformity of 100%, but it is not happening that way with sprinklers. But we will see it. We see how is it measured. So, how do we measure the water distribution uniformity? It can be measured in the lab, or it can be measured in the field. Now, what do? We actually take our sprinkler, the same flow rate, in the same operation pressure, and we install it on the field, in a grid of 16 sprinklers, so 4 by 4. You can see here 16 sprinklers, and we set in the center of the grid we set a catch cans like a rain gauge or containers, and then we open the water and run the sprinklers for 1 hour. Then what is happening is that those rain gauge are collecting the water, and after we collect the water, we take this amount of water in each cans, in each container, and we calculate the CU, the DU, and the SE. So this is how it is done in the field. You can see the sprinklers along the field, and you can see the catch cans. It should be located in a very, very precise way with a very precise distance between the catch cans. So this is how it's done in the field. And after we operate the water, we collect the water in the catch cans, and we measure them. We measure each catch can, how much water it collected. And we take this data, and with not very complicated, but a little bit mathematical calculation, we can calculate the CU, the DU, and the SE. And you see that according to this example, and this is an example, and you see that the CU in this case is 97%, great. The DU is 92%, also great. And the SE is a little bit high, 1.3, according to this example. Now, so we get the CU, the DU, and the SE. What do we do with that? How can we interpret the result? So here you have some kind of a table that you can ask yourself: is it good? Is it bad? Is it okay? So I can tell you that in open field, excellent uniformity expressed by a CU of above 92%, when the DU is above 90% and the SE is lower than 1.1 or 1.15. Those numbers are relevant for open field, but when you irrigate in greenhouse, and when in greenhouse you have like moving tables or soilless or even pots, then you need to have a higher water distribution uniformity. So in greenhouses, you would like to achieve a CU of 94% or 95% and higher to get an excellent water distribution uniformity. So just an example, you see here in the right picture an example of what is a poor water distribution uniformity and example of what is a good one in the left picture. And why is it poor? Because what you see here on those circles, you see a pattern that repeats itself along the row. Now this pattern is coming from spots that are over irrigated, and in over irrigation we have a problem. In over irrigation in this way, the crop will not be uniform, and the yield will not be good. Now we can improve it. So just to tell you what are the factors that are related on the water distribution uniformity. So there are factors that are related to the internal design of the sprinklers, and there are factors that are related to the working conditions. Now let's start with the factors that are related to the internal design of the sprinkler. I can tell you that the main factors is the water passage, the design of the sprinkler itself, the nozzle size, the nozzle shape, or if it is a single nozzle or a double nozzle, the rotation technology, if it is an impact sprinkler, dynamic, static, whatever. Each one of those factors that are related to the design of the sprinkler will later on influence on the way that the water will be distributed out of the nozzle. And when you take this sprinkler or micro sprinkler and you add to it the operation conditions like the inlet pressure of the sprinkler, the height above the surface, the irrigated surface, if it is 1 meter above the ground or 2 meters above the ground, then it influences the water distribution uniformity. And of course, the installation spacing and installation pattern also will influence the distribution uniformity. Here, on the center, you can see installation, which is, we call it full coverage. So it is the sprinklers are overlapping in between themselves in a full coverage way. We have the single line irrigation that usually used in tunnels, or the double line irrigation that also used in tunnel in a wider tunnels. So those are the factors that eventually will influence the distribution uniformity. Now let's take an example, and I want to tell you that you don't need to test the sprinklers by yourself. We did it for you. We developed a software that's called NetSpecs. You can go to netspecs.netafim.com, and if you are not registered already, so please register to NetSpecs, and you will have all the data of all our Netafim sprinklers inside NetSpecs. So you see here a Spinet. This is Spinet flat 160 liter per hour. This is the way that the water is distributed. We call it a single leg profile. This is the way that the water is distributed as a single emitter. Now, if we take this specific emitter and we install it on a greenhouse in a full coverage with the rectangular installation of 2.4 meter by 3.2 meters, then what you see, this is an output of NetSpecs. It calculates everything for you. So what you can see here is that you can see the CU, the DU, and the SC, and the precipitation rate. So you can see that the CU is 95.79%. This is a very, very good water distribution uniformity. The DU is 94%, and the SC is lower than 1.1, is 1.09. So please use this software of NetSpecs, and then you will be able to make all the calculation. It will do all the calculation for you. You don't need to do it, but you will get all the data out of NetSpecs of the CU, DU, and the SC of the water distribution uniformity. And always remember, you can influence the water distribution uniformity. And now I'm asking you, it's a question for you. If we have a case of a poor water distribution uniformity, how we can improve it? Now I will go and I will submit you a poll, a question that will pop up on your screen, and please answer the question. So I will give it a few more seconds.
Great question, Orit. While everyone is answering the poll, I want to say thank you for your great questions so far. You're welcome to ask more questions. The chat is private and only Orit and I can see it. And good luck in the poll.
So thank you, everyone. I will now close the poll. And I can see your answers, and thank you for that. And please note that you need to answer the poll in order that the pop-up will go out of your screen. So how can we improve it? Part of you said change the sprinkler spacing. Part of you said change the spacing pattern or change the sprinkler itself. And part of you say that all of the above are correct. So I can tell you that in some cases, just by changing spacing of the same sprinkler can increase the water distribution uniformity, or changing the spacing, the pattern, installation pattern from rectangular to triangular will also influence. And in some cases, like this poor water distribution uniformity, we will need to change the sprinkler because otherwise it will not be possible. So another example of a poor water distribution uniformity, on the top you see two pictures of a greenhouse that in each bay the beginning was just two lines that with upside down irrigation with a micro sprinkler, and what you see here are very like a pattern that repeats itself of dry spots and wet spot and dry spot and wet spot. But what we did in order to improve it, we actually add to this bay, because it was a wide bay, more than 10 meters, we added another line. So we call it a triple line per bay. We added another line of the same micro sprinkler, and you can see the improvement and the results. And I can tell you that at the beginning, the farmer was disappointed, and after we did the change, he was relieved because the performance were very good. So we talked about precipitation rate, water distribution uniformity, and now I'm moving to the another factor that affects that we need to understand in order to select a sprinkler. We call it evaporation loss during sprinkler irrigation. Remember, sprinklers in open field, when when there is wind, high wind on the field, then the sprinkler, or the water that are spreaded from the sprinkler itself, can be evaporated to the air. So please pay attention. If you can work in a condition of lower wind, this will be good. And now other factors that we have, like relative humidity or air temperature, will also influence on the evaporation rate of the water that we distribute to the air. And we don't want to lose water to the air. We don't want that the water that is spread by the sprinkler will be lost for the air itself. So please pay attention for that also. Now, another thing that we need to pay attention when we design a sprinkler system is what we call the maximum length of the lateral and the head loss in the riser tube. Now, maximum length of the lateral, the distribution pipe that the sprinkler are attaching to, you can calculate what should be the maximum length of the lateral in order not to lose performance of the sprinkler. And the maximum length, it depends on the sprinkler flow rate, it depends on the spacing between the sprinklers, on the lateral line. In general, you don't want to lose more than 10% in flow from the inlet of the lateral to the end of the lateral, and you don't want to lose 20% in pressure from the inlet to the outlet. Now, remember that you can calculate all of that in our HydroCalc. So HydroCalc is also a software that we Netafim developed. Just register to HydroCalc, hydrocalc.netafim.com, and you can calculate everything, a lot of hydraulic calculations that you will have there. And another thing that I want to refer to when I'm talking about factors that affect our design or that we need to know is what we call the emitter water trajectory. Now, it is more important when you work in greenhouses. In greenhouses, as you see in the picture, the emitters, the micro sprinklers are installed in an upside down way. Now, above the micro sprinklers, there are fans and lights and distribution pipes and heating pipes, etc., etc. And if the trajectory angle of this micro sprinkler is high, then water can touch the heaters or the other devices that are above it. So if you need to know what is the free spacing or the what we call the maximum height above the sprinkler that the water are distributed. So please ask us. We have this data, and then you will need to make sure to save this space, or to make sure that you have this space above the emitter in order not to damage the other devices. Now, I want to finalize what I talked about, the factors you need to consider when choosing a sprinkler. So it is very important to make sure that all those 5 factors will be kept: water distribution uniformity, maximum length of the lateral, and evaporation loss, and all those factors. And I want to share with you a short video when good design of a sprinkler system is done on the field. So that project was from Hungary, and I guess that you saw that you saw a good a design, a very good design, and a good water distribution uniformity, selecting the right sprinkler, selecting the right spacing, and design the distribution pipe according to the rules and principles. Now, I want to move to the last section of this webinar, which is the main market segments that we in Netafim are referring to with our sprinklers. So I can tell you that we are active in different market segments in agriculture. So in open field, when we talk about open field crops, in orchards, in protected crops, greenhouses, and also in mining. Now, when we talk about open field irrigation, we always talk about using big sprinklers and not micro sprinklers that are installed on the field, and we have a very large area that we want to cover. So we call it a full coverage with less emitters per hectares. The main uses are for germination of crops like wheat, and a complete irrigation of the whole crop season, like potatoes, carrot, peanuts, onion, and other field crops. So for that, we use our MegaNet or our all the DNet family. We have many different of flow rates and different models of those sprinklers. You can find everything in the catalogs and in the website. So please feel free to check our catalog for open field. Another market segment that we are active in is a very interesting market segment. We call it orchards. So orchards, I'm talking about trees like almonds, like avocado, like lychee or mango, or other deciduous apples trees. And in orchard, we don't do only under tree irrigation, because usually install this micro sprinkler, this SuperNet or GyroNet, below the tree for under tree irrigation. But not only that, we use also our micro sprinkler for different uses as frost protection and heat wave protection in order to protect the tree from extreme weather events. And I can tell you that we will have a webinar that deal with only with extreme weather events and how do we use micro sprinkler in order to reduce damage of extreme weather event. And also we use micro sprinklers for what we call a permanent spray system. So we spray chemicals above the trees in order to avoid diseases. So this is in orchards and in protected crops in greenhouses. We have many types of micro sprinklers as our SPINNet and SPINNet SD and VibraNet and CoolNet. We always in greenhouses install those micro sprinklers in an upside down way. The idea is that we use it for cooling, humidification, rooting, germination, irrigation, and the main advantage is to cover a large area or dense crop with the micro sprinklers above the crop. Also, another market segment that we are active in with our sprinklers is mining. Mining, we have the main uses is for heap leaching of taking the copper or the gold or the silver, depends on which mine is it, from the soil. And also we use sprinklers for evaporation of a large amount of water in pools that there are in a mine. So this is the use of our sprinklers in mining. And in mining, usually in a copper mine, usually they use high concentrations of acid, and we produce our GyroNet Turbo, the purple one that you see here, the nozzle and the bridge from material that is actually resistant to those high concentration of acid. So this is also interesting. I would like to summarize a little bit what we had here today in this webinar. Remember, we had 3 sections. One was sprinkler, micro sprinkler. The second was all the terms that we needed to know in order to select our sprinkler. And the last one was a little bit of our portfolio and market segments. So the summary and takeaways. So I can tell you, sprinklers have long history. It was developed back then, many years ago. The idea was to bring efficiency and reduce labor and labor cost on the field. Now, Netafim always continues to innovate and to develop more and more sprinklers, more and more micro sprinklers that and solutions, the full solution itself, in order to answer all the needs that we find on the field. We have many new products that are on our development table that will be introduced to the market. So it is very interesting. Now, remember that in order to achieve highest performance of your crop, highest as possible, make sure first to select the right sprinkler according to the application. And always consider the 5 important factors that we talked about it, and don't compromise on the water distribution uniformity. This is absolutely critical. Now, if you want to check water distribution uniformity of all Netafim sprinklers, just register to NetSpecs software. It is available online. It is available also on your as a mobile app, but just register online on the web. NetSpecs will give you an easy way to calculate the water distribution uniformity. You don't need to do it by yourself. And last one, Netafim offers very wide and enhanced portfolio of sprinklers, micro sprinklers, and emitter for any agriculture need or any agriculture use. Whether it doesn't matter if it is an irrigation or germination, cooling, humidification, frost protection, heat protection, or crop protection. Now, if you need a help to understand which sprinkler is going to which application, just visit our website, visit our NetSpecs, and you will find all the answer. And of course, you can also always contact us, and we will answer every question that you have. So thank you.
Thank you, Orit. Was great. Thank you very much. Let's answer the questions we received on the Q&A chat, and feel free to keep adding more questions.
Okay.
What is the reason for irrigating with sprinklers and not drip lines?
Oh, this is a good one. I can tell you, Shachar, that always when I travel the world with and visiting our farmers, always I ask this question, okay? And people can tell me that in some cases there are applications that cannot be done with the drip lines, like frost protection, like heat protection, like a spraying system or cooling or humidification. This cannot be done with drip lines. Now, if we talk about irrigation, it is very depends on the soil. In a rocky soil or in a soil that you don't have a good movement of water inside the soil, then when you use drip, not always you create like a wetted area that is enough for your root zone. So you need to irrigate, and under tree irrigation by micro sprinkler. And of course, in open field, it is much more efficient. It covers much more large areas, and you use less emitter per hectare.
Great, you got me. Is there a quick and smart way to compare between the different Netafim sprinklers?
Yes, there is. Just go to NetSpecs. Inside the NetSpecs, you will find three main functionality. You can check if you know your sprinkler. You can just check the performance according to the conditions that you have on the field. If you don't know your sprinkler, but you do know your application on the field, NetSpecs will find you the best sprinkler according to the application. And if you want to compare, there is a possibility to compare up to 4 sprinklers or 4 sprinklers in a different models, and to get the comparison of the water distribution uniformity and the average precipitation rate between those sprinklers.
Yes, great tool, the NetSpecs. There was no reference to landscape. Is there a difference between sprinklers for landscape and sprinklers for agriculture?
This is a good one. I can tell you that we in Netafim, in the corporate, we don't develop sprinklers or micro sprinkler for landscape, but part of our portfolio can also be used in landscape, and this is happening. Now, the reason for that is that landscape is a different way of irrigation. The requirements are very different from agriculture. We decided to focus on the agriculture area and not in landscape, but still part of our portfolio of our micro sprinkler can also be used in landscape.
Okay. Can the MegaNet work in copper mining?
Okay, so this is a good question. I mentioned in the mining section that for copper mine, they use a high concentration of acid for the heap leaching process, for the leaching process of taking the copper out of the soil. So they spread water with a very high concentration of acid. Now we have the GyroNet turbo that we inject the parts of the GyroNet turbo from raw material that are resistant, are very resistant for those high concentration of acid. And regarding the MegaNet, still the turbine of the MegaNet can be damaged by high concentration of acid. So I don't recommend to use it now. We are working on a different, maybe we will have in the future something that we will have resistant to also in the MegaNet for high concentration of acid, but this is it's not available yet.
Challenging. Nice. Last question. Does topography have an effect on water distribution?
Wow, great question, and thank you for that. Absolutely yes. Why? Because most of the sprinklers, the open field sprinklers, are non-pressure compensated, are not flow control or pressure compensated. Now remember that in our take our drip lines, Uniram or DripNet, it's a pressure compensated dripper, and there is a mechanism inside the dripper that compensate the differences of the pressure. So the output of the water out of the DripNet or the Uniram is the same amount of water in different pressure. Now, if you have a topography, a change in topography on the field, and you use, let's say, MegaNet or DNet without a pressure compensation mechanism, then for sure, along the lateral, you will have differences in the inlet pressure of the sprinkler, and this will influence the flow rate of the sprinkler and also the way that the water is distributed. Now, I can tell you that there are ways to overcome it. We can use a pressure regulator device that at the inlet of the sprinkler of the DNet or the MegaNet, and in this case we overcome the change in topography and the changing in the pressures. So there are ways to overcome it.
Great. Thank you, Orit. Thank you very much. Okay, let's wrap it up for today. Thank you, everyone, for your attention during this webinar. And see you next time for another great live presentation.
Thank you. Bye-bye.
Bye-bye.